Welcome back to the physics class, dear students. So in the previous class, we discussed some of the concepts which especially relates to the optical instruments. So that in that before the previous class, I just explained you that we are going to combine the two lenses. So why we are just combining of the two lenses? Just to increase that the strength of the power of the combination of lenses. Suppose if I just use only a single lens, the power is very less. So whereas if I just combine the two lenses, focal length reduces for the combination of lenses and the power increases. So why I am repeating this concept again? Why? Because today's class I am just moving towards the next part of an optical instrument, that is what? The compound microscope. As well as before moving towards the compound microscope, so as I said before in the previous class that I just derived the angular, that is what? A linear magnification in case of a simple microscope. Now I am moving towards the derivation of the angular magnification for the same simple microscope. Now let us move towards the derivation of expression for angular magnification of simple microscope. My dear students, before going towards the deriving of expression, we should know the design and also the working principle of this simple microscope for deriving this angular magnification. So first I am moving towards a writing of the diagram. See my dear students, I am just considering a convex lens. So whereas in the previous class I just said you that this convex lens or the magnifying lens or the reading lens is simply called as a simple microscope. See here, which is having a principal axis. Here again I am just going to write the optic center which is present here, whereas the lens is represented by xy, so which is having a two apertures, two convex surfaces towards the radar medium. Now here this lens is having a principal focus and center of curvature on both the sides. Here in this case I am going to place an object, say A, B. So this AB is an object which is placed at principal focus. You know, in the previous class I just shown you the ray diagrams in which suppose if we place an object at the principal focus, the image is formed exactly at the infinity. And the vice versa cases, that if we place an object at infinity, we'll get the image at focus. Here I just placed an object AB at the principal focus. See, from the AB I am going to observe a ray, that is what? A parallel beam of light which is parallel to the principal axis falls in the convex lens. While this parallel beam is going to incident on the convex lens, it undergoes refraction and refracts through the principal focus. Similarly, I am using another one ray to define it very clearly. I am just going to use another ray, the ray which is going to fall, which is going to pass through the optic center. You know that if any of the ray passes through the optic center, it passes out without refraction. It passes out without refraction. So dear students, you should be very careful that I just written the ray diagram by just placing an object at principal focus Here the refracted rays are parallel to each other. These two refracted rays are exactly parallel to each other. If the refracted rays are said to be parallel to each other, it shows that the image is formed at infinity. The image is formed at infinity. Right, this is clear. But then how to derive the angular magnification? See dear students, I said you while defining the angular magnification, that is what the angular magnification is written as the ratio of theta I by theta naught. Even this angular magnification is defined as the ratio of angle subtended by the image at the eye to the angle subtended by the object at the eye. So simply written it as theta I by theta naught. But you should be very careful that while you are discussing regarding this theta I and theta naught, because V and U is very easy for us to write, is very easy for us to substitute, and also HI by H naught is also very easy for us to write and very easy for us to substitute from by observing the diagrams. But here, how to get that theta I and theta naught? Dear students, as I said you before, theta I is a angle subtended by the image at the eye. See here, the observer is exactly at this position. The observer is exactly at this position, right? The eye is at this position. The eye is at this position, right? Observer is at this position. Then the angle subtended by the image is somewhere else at the infinity, that is said to be theta I. According to mathematics, if this angle is considered as theta I, so this angle also should be equal to theta I itself, my dear students. Right? Then I just want to move for theta naught. To move for the theta naught, we have a working principle for this simple microscope in case of calculating the angular magnification. What is this working principle? As you know that previously, that is what I just said you, in case of calculating of linear magnification, in that case, if the object is placed between the optic center and the principal focus, the image is formed, the virtual, erect and the enlarged image is formed at a least distance of distinct vision beyond the center of curvature. But now, in this case, it's completely different. See, if in this case, the working principle is, if an object is placed at, the principal focus, so that the image is formed at infinity, it is assumed that if the object is placed exactly at the least distance of distinct vision. See my dear students, you should be very careful that while writing of the working principle in case of calculating this virtual angular magnification. So that is what? Here the image is exactly formed at infinity. If it is, see I am using if it is assumed that the object is placed at a least distance of distinct vision. I am just repeating again. See here, here you can write your working principle. The image is formed at infinity for a simple microscope when the object is assumed to be placed at the least distance of distinct vision. That is said to be the working principle of this simple microscope, that is for the case of angular magnification. Now in this, how to assume here? See, I am just assuming that the object is placed here. The object is placed at least distance of distinct vision. See, this is an object which is assumed to be placed at least distance of distinct vision, that is placed at B. Right. So this is object distance, dear students. It is said to be the object distance, that is U naught. And then, what is an angle subtended by this object? See, the angle subtended by this object is theta naught. The angle subtended by this object is theta naught. See, hope you got all the things that I written here. And the distance between between optic center and the principal focus is focal length, represented by small f. Now, so write some points for this. See, you can write that when the object AB is placed at principal focus, a real, inverted and greatly magnified images formed at infinity. So my dear students, I just said you that the working principle in case of angular magnification, that the image is formed at infinity. The image is formed at infinity if the object is assumed to be placed at the least distance of distinct vision. Why I just said, so to calculate the angular magnification. Or write the simple working principle for that. I am just writing up the simple working principle for this. Working principle for this. Working principle for this. See, where the object is placed at principal focus, where the image is formed at infinity. What is the nature of the image? It is real, inverted and enlarged. So I am writing it. When the object is placed at focus, comma, the real, inverted and enlarged image is formed at infinity. See, this is almost all the working principle that we use for the examination. Right, this working principle for examination. Some textbooks even they give that the image is formed at infinity for calculation of an angular magnification. Suppose if the object is assumed to be placed at least distance of distinct vision. No problem, you can write this working principle. So that write aura and write the working principle also. Now you can see here, so just written the diagram because we are assuming that the object is placed at least distance of distinct vision. So that we just placed the object at this position and we written that the angle theta naught. Dear students, this is only the assumption. So now let us move for this angular derivation of the expression for angular magnification. Then by the definition of angular magnification, how to write m? M can be written as theta naught by theta I by theta naught. Then for smaller angles, see theta I can be written as tan theta I and theta naught can be written as tan theta naught. Right. So we know that tan or sine values can be equated to the angle and the angle is very very small. So but in theta and theta naught ಅನ್ನು deduce ಮಾಡಬೇಕಾಗಿರೋದ್ರಿಂದ ನಾವು replace theta I and theta naught by tan theta I and tan theta naught just by using the trigonometry. So that tan theta I divided by tan theta naught. So I want to calculate the value of tan theta I and also I want to calculate the value of tan theta naught. So now where is theta? Theta is here. So it is in the triangle OAB. And where is theta naught? Theta naught is here. It is in the triangle OA dash B dash. So now let us consider the two triangles from triangle OAB. Right, from the triangle OAB. What is the value of theta I? Tan theta I. So tan theta I is equal to, you know that the tan theta can be written as opposite by adjacent. Here opposite is AB, adjacent is OB. So I am writing it AB by OB. Right, AB by OB. And my dear students, even I am just going to calculate the value of which one? Tan theta naught. So from triangle, which triangle I am using to calculate theta naught? OA dash B dash. So from the triangle OA dash B dash, how to calculate tan theta naught? Tan theta Now let us substitute this in the above equation. Therefore, M is equal to AB divided by OB whole divided by AB divided by OB dash. So A dash B dash divided by OB dash. So this is what the terms that we represent here. So then what is OB? Heads up. What is OB dash? It is D. Okay, it's almost solved. So simply we can write this in this way and we can solve it very carefully. But should be very careful that while writing out. So you should be very careful, my dear students, while writing out the terms that what is AB and what is A dash B dash and what is OB and also what is OB dash. Because in the previous class, that is what while deriving the linear magnification in case of a simple microscope. So it is very easy that you have a substitution of V and you have substitution of U. But here it is very different. It is what you just written it as that is what tan theta is equal to AB divided by OB. So okay, what is AB? Because opposite by adjacent when it becomes to the question. So OB is said to be that distance between optic center and the principal focus called as focal length. Then what is this AB? AB is the height of the object. So you can write it as h naught divided by small f. H naught divided by small f. Not only that, even when you come towards writing of A dash B dash divided by OB dash, A dash B dash divided by OB dash, we can observe that what is this A dash B dash? It is as similar to that of AB. So it means A dash B dash is also the height of the object. So that here I am writing it as h naught. Then what is OB dash? OB dash is the least distance of distinct division. Write it as D. So finally we came to the conclusion that so that h naught by f and h naught by d. Here I am just substituting it directly. So that h naught divided by f divided by h naught divided by d. Right? Because AB is also an object, A dash B dash is also an object. But according to the working principle, AB is at f, image is at infinity. But for the calculation of this angular magnification, we assume that the object is placed at least distance of distinct vision. So now here h naught cancel with each other. Finally we will get d by f. Dear students, finally we got the formula, whereas the angular magnification in case of a simple microscope is equal to capital D by small f, whereas D is the least distance of distinct division and f is the focal length of the given lens. So this is about the angular magnification in case of this simple microscope. I just want to recollect this again. So I just considered a convex lens in which I placed a object AB at the principal focus. The parallel beam of light after refraction passes to the principal focus, and the ray which is passing to the optic center, it passes out without refraction, whereas these two are the refracted rays which are parallel to each other. So if the two refracted rays are parallel to each other, they never meet at anywhere. So easily we can say that the image is formed at infinity. Then what is the working principle? Simply you can say that when the object is placed at AB, that is when the object is placed at principal focus, the real inverted enlarged image is formed at infinity. Right. But here to calculate the angular magnification, so that in some lesson they given that to calculate the angular magnification of a simple microscope, if the object is assumed to be placed at the least distant of distinct division, then the enlarged real inverted image is formed at infinity. This is what the assumption that we made. So according to our assumption, so according to the definition of the magnification, whereas the angle subtended by the image at the eye is theta I, according to mathematics, if this is theta I, this angle should also be equal to theta I. And one thing, my dear students, we assume that the object is placed at least distance of distinct division. So that I am going to assume, I just written it in the dotted lines, that A dash B dash is an object which is assumed to be placed at capital D. So that the angle subtended by this A dash B dash, the eye is said to be theta naught. Whereas OF is focal length and OB dash is D. Now by the definition, M is equal to theta I by theta naught. I cannot calculate theta I, theta naught directly. To calculate the theta and theta naught, I am using a small angle so that the small angles can be equated to the tan theta and tan theta naught. So that I am just replacing theta tan theta I in place of d theta I and tan theta naught in place of theta naught. Just by substituting it here, I just used the triangle OAB and OA dash B dash to get the value of tan theta I and tan theta naught. So whereas AB and A dash B dash is said to be the height of the object because it is an object and it is an assumed object, so both are same, so that h0 and h0 will be high. Whereas OB is said to be the focal length represented as small f and OB dash is said to be the least distance of distinct which is written as d. Just by dividing tan theta and tan theta naught, you got which is equal to d by f. So this is what the expression for the angle of magnification in case of simple microscope when the object is assumed to be placed at the least distance of distribution. So this completes your simple microscope. Now we are moving towards the discussion of the compound microscope. Hope you all observed the compound microscope in your biology lab the previous years. So that how actually this compound microscope is going to work. So now we studied the simple microscope, right? So where the simple microscope used? The simple microscope is used as a magnifying lens, it is used as a reading lens, it is used by the watchmakers, right? My dear students, see actually the simple microscope is having a lot of applications, as even the simple microscope is used by the dentists. I am repeating again, it is used by the watchmakers, it is used by the dentists, and even it is used as a magnifying lens and it is used as a reading lens. Okay then, let us move to the compound microscope. What is this compound microscope? Dear students, obviously it is an optical instrument. Compound microscope is an optical instrument. Right, compound microscope is an optical instrument which is used. What you are using? So you might have observed the compound microscope in your biology lab, so that you use that to see the tiny objects, right? This tiny objects which is used to see the tiny objects clearly and distinctly. So that this is an optical instrument. With this instrument is used to see the tiny objects very clearly. So that it is used to see the microorganisms. So simply we can say that we are just going to mount the slide and we are going to observe the microorganisms with the help of microscope, especially the compound microscope. And you might have experienced and you might have seen the two lenses which are present in the compound microscope. Hope you are getting. So just remember that my compound microscope is present in front of your eye, so that it is having two lenses. So this compound microscope is it is made up of two lenses. It is made of two lenses. Why it is made of two lenses? Dear students, already I said to invert the inverted image. That is what? To get the erect image and also to magnify the image to the extent and to see the clear image and to increase the power, to reduce the focal length of the single lens. We are just moving towards the combination of lenses. Similarly, here in the compound microscope, we are just moving with the two lenses. So I am just moving towards the discussion of the construction of compound microscope. Yes, construction of compound microscope. What's the construction? So how to discuss? See, as I said you before, the optical instrument or the compound microscope is having two lenses. Whereas where these two lenses are exactly kept? These two lenses are exactly kept at two ends of the adjustable tube. So that why I am just saying that the two ends of, actually the two lenses are placed at the ends of, two ends of the adjustable or sliding tube. Why this we can even adjust the position of a objective lens with respect to the eyepiece. See my dear students, I am repeating again. So whereas this compound microscope is constructed by using two lenses, whereas those two lenses are said to be the convex lens, right? Whereas the two lenses are placed on either side or at two ends of adjustable tube. And one thing is, here we have two lenses, right? Then you may get the question, what about the focal length of the two lenses? Whether the focal length of the two lenses are same, or whether the focal length of the two lenses is different, or whether it is of what we can say that the same power. These students, obviously the focal length of the two lenses are different. The lens which is near to the object, near to the slide is called as objective lens, and the lens which is towards the eye, that is what towards the observer, is called as eyepiece. I am repeating again, we have the two convex lenses which are placed at the two ends of the tube, which is adjustable or which can be slide easily. And one thing is, whereas these two convex lenses are of different focal length, the lens which is placed near to the object, near to the slide, is called as an objective lens, and the lens which is placed towards the observer, or even the lens which is placed towards the eyepiece, it is said to be the eyepiece. Dear students, then what is the focal length of objective lens and what is the focal length of eyepiece? The object, that is what the focal length of an objective lens is very small, as well as the aperture is also very small, but the eyepiece is the one which is having a more focal length and which is having a more aperture. So hope you just got the things that what I just explained you now. Take down the points that what I am going to say it in the construction part. So just note down that I am just going to read out the things. So just pause the video while you are observing it and write it down. So I will just read it continuously. So it consists of two convex lenses arranged coaxially at the ends of two sliding metal tubes. So the lens towards the object is called objective lens, whose focal length and the aperture is small. Full stop. In the next line, the lens towards the observer is called eyepiece, whose focal length and aperture are comparatively large. In the next line, the distance between the eyepiece and the objective can be varied by using rack-on pinion arrangement. Yes, this is about your observation. So that what I just read you now. So those things that you right. So dear students, I am just repeating again for you. So that the two lenses that what I said, both are having a different focal length. One is of more focal length and another one is with less focal length. So that is what the objective lens is the one. The objective lens is the one with very less, that is what small focal length, and the eyepiece is the one with large focal length. So hope you return this. Now let us go towards the working principle. Dear students, construction part alli ನಾನು ಏನು ಒಂದು ಸೆಂಟೆನ್ಸಸ್ ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದೆ ಅದನ್ನ ಕಂಪ್ಲೀಟ್ ಬರೀಲಿಕ್ಕೆ ನಾನು ಹೇಳಿದ್ದೀನಿ. ಸೊ ಅದನ್ನ ನೀವು ಪಾಸ್ ಮಾಡ್ಕೊಂಡು ವಿಡಿಯೋನ ಬರೀತಾ ಹೋಗಬೇಕು, ರೈಟ್? ಸೊ ನಾನು ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಅದನ್ನ ಹೇಳಿದ್ದೀನಿ, ನೀವು ಅದನ್ನ ಪಾಸ್ ಮಾಡ್ತಾ ಮಾಡ್ಕೊಂಡು ಹೋಗಿ. ಸೊ ನಾವೀಗ ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ನೋಡೋಣ. ಸೊ ನಾನು ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ನೋಡೋಕ್ಕೂ ಮುಂಚೆ ಅದನ್ನ ಸೆಂಟೆನ್ಸ್ ಅಲ್ಲಿ ಬರೀಲಿಕ್ಕೆ ಮುಂಚೆ ನಾನು ಏನು ಮಾಡ್ತಿದ್ದೆ, ಡಯಾಗ್ರಾಮ್ ನ ಬರೀತಾ ಹೋಗ್ತೀನಿ, ರೈಟ್? ಸೊ ಜಸ್ಟ್ ಟೇಕ್ ಡೌನ್ ದ ಡಯಾಗ್ರಾಮ್ ಅಂಡ್ ಆಲ್ಸೋ ಡಯಾಗ್ರಾಮ್ ಬರ್ಕೊಳ್ಳೋದ್ರ ಜೊತೆಗೆ ನಾನು ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೀನಿ. ಸೊ ಆಗಲೇ ಹೇಳ್ದೆ, as I said you before, I have the two lenses, right? So I am going to place the two lenses. Two lenses are convex lenses, right? Now both the lenses, those two lenses are having a principal axis. Yes, both are having optic center. See, the objective lens is placed towards the object, and now with larger focal length and also large aperture, which is placed towards the observer, called as eyepiece. Dear students, these two lenses are always placed coaxially. It means the axis of both the lenses are exactly parallel to each other. So that is what the arrangement. Construction part of the first point adane heliddu. Then these two lenses are kept at the ends of the two sliding tubes. So it means we can adjust the distance between the two lenses. And the objective and the eyepiece the distance we can adjust it like that arrange. So I'll just extend this again. Yes, now you can observe it very carefully. Now what I am doing, now I am just going to place the object. Now I am going to place an object, say A, B, right, which is placed beyond F0. It means it is placed between center of curvature and principal focus. See, if I just place object between a principal focus and the center of curvature, where will the image is formed? Image is formed exactly beyond C. Now I am writing, here it is. So capital F ಅಂತ ಬರಲಿಬಹುದು, direct F0 ಅಂತಾನೆ ಬರೀತಾ ಇದ್ದೀನಿ ನಾನು. So which gives you clear recording focal length. Yes. Now, if a parallel beam of light incident on a convex lens, after refraction, it passes through the principal focus. Right. Now, what is writing as F itself, no problem, F0. Yes. Now, I am using another one, right, which is passing through the optics area. It passes without refraction. So it passes without refraction. It should be very straight, my dear students. Line must straight ಆಗಿರಬೇಕು, so it should not bend. So it is very lengthy, so that I am going to bend the lines. Yes. It should be very clear. Now where the image is formed. The image is formed here. So that here it has been inverted B dash A dash. My dear students, now we can observe it very carefully that. Idu tumma neat aga observe ಮಾಡಿ. So object ಅನ್ನು place ಮಾಡಿದ್ರೆ object is placed beyond F0 of the objective lens. So then objective lens image formation ಮಾಡ್ತು beyond C. Right. Now this point is a principal focus of eyepiece. That is what? The distance between this principal focus and the optic center is called as the focal length of eyepiece. Please be careful. Now where the image is formed? Image is formed beyond the center of curvature, and that point is exactly the principal focus of eyepiece. See, I am just repeating again, don't confuse with the things. We have the two lenses. The two lenses, one is said to be the objective, which is having a less focal length and less aperture, and the lens with larger aperture and the larger focal length is called as eyepiece. Now, where the object is placed? Object is placed beyond F0, beyond the principal focus of objective lens. So now, if I just consider the two rays, it form the image beyond center of curvature, whereas that point is the principal focus of eyepiece. However, A dash B dash is the image for objective lens, and A dash B dash is the object for eyepiece. Right? See, the objective lens formed inverted real enlarged image at beyond C, whereas the object A dash B dash is at principal focus for eyepiece. If the object is placed at eyepiece, then after refraction, see here I am just going to place an eye. Here the observer is, so that after refraction, you know that if the object is placed at principal focus, image is formed at infinity. Yes, students, so that Here it is at principal focus. So it formed an image at infinity. But if I extend this, I got an image at this position. I got an image at this position. See, there's a lot of construction is present in this. There's a lot of construction is present in this compound microscope. But it's very easy if you understand. So keep in your mind, the two lenses are exactly arranged coaxially with each other. One is said to be the objective lens with less focal length and less aperture, and the lens with greater focal length and the greater aperture is called as eyepiece. And one thing, where the object is placed, see, I am repeating again and again. Beyond F0, image is formed. Sorry, in between C and F0. Because beyond F0, you may get confused. So it is between C and F0. Then the image is formed. The image is formed at the beyond C. That is what A dash B dash is an inverted real and enlarged image is formed. Whereas the image formed by the objective lens acts as an object for eyepiece. Whereas this object is at principal focus, then it forms an image at infinity. So we can say that the image which is formed is at the least distance of distinct vision. The image which is formed is at least distance of distinct vision. This is a final image distance. This is the final image distance. So that this is an object distance which is equal to F0, and this is a focal length of objective lens, that is the distance between optic center and principal focus, whereas the distance between the optic center of an objective lens and the AB object is said to be the object distance represented by U, and the image is finally formed at least distance of distinct vision. Hagadre, how to write the working principle? See, I am just consolidating you. So when the object is placed between the center of curvature and the principal focus of the objective lens, the image is formed beyond center of curvature. So that the image which is formed by the objective lens is real, inverted and enlarged. And the image formed by the objective lens acts as an object for eyepiece, and that object which is exactly at the principal focus of the eyepiece, and it forms an image at least distance of distinct vision. Now my dear students, see, you can observe that. Here in this case what we are just using it here. So ಇಲ್ಲಿ ನಾನು ಏನು ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಆಬ್ಜೆಕ್ಟ್ ನ ನಾವು ಎಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡ್ಕೊಂತಾ ಇದೀವಿ, ಫಸ್ಟ್ ಬಿಯಾಂಡ್ F0, ಆಮೇಲೆ ಅಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಯಿತು, ಅದನ್ನ ನಮಗೆ ಎಲ್ಲಿ ಫೈನಲ್ ಆಗಿ ಇಮೇಜ್ ಸಿಕ್ಕಿದೆ. ದಟ್ಸ್ ವಾಟ್ ಇಸ್ ಸೆಡ್ ಟು ಬಿ ದ ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್. ಸಿಂಪಲ್ ಆಗಿರೋ ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡೋದು. ಸೊ ಟೇಕ್ ಡೌನ್ ದ ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್. ಐ ವಿಲ್ ಜಸ್ಟ್ read it out, just write it down. So when an object AB is placed just outside the principal focus F0 of the objective lens, a real, inverted and a magnified image A dash B dash is formed on either side of a lens beyond 2F0. See, ಅಥವಾ beyond center of curvature ಅಂದ್ರು right, no problem. Full stop. Next line ಬರ್ಕೊಳ್ಳಿ. So the image of objective lens acts as an object for eyepiece. Dear students, in the next line, the distance between the object and the eyepiece is adjusted so that the final image is formed at least distance of distinct vision of the eye. Okay, so ಈಗ ನಾನು ಏನು ಇಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ನೀವು ವರ್ಕಿಂಗ್ ಪ್ರಿನ್ಸಿಪಲ್ ಆಗಿ ಬರ್ಕೊಂಡ್ರೆ, ಪಾಸ್ ಮಾಡಿ ಬರ್ಕೊಂಡ್ರೆ. ಸೊ ನಿಮಗೆ ನೇಮ್ ಗೊತ್ತಿಲ್ಲ, the final image is represented by B double dash and A double dash. ನಾನು ಹೇಳಿದೆ, so the two lenses are exactly placed at the ends of two adjustable sliding tubes ಅಂತ ಹೇಳಿ. ಹಾಗಾದ್ರೆ ಅದನ್ನು ಕೂಡ ನಾವು ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ನಾವು ಯಾವ ತರ ಅಡ್ಜಸ್ಟ್ ಮಾಡಬೇಕು ಈ ಲೆನ್ಸ್ ನ ಅಂದ್ರೆ, ಈ ಲೆನ್ಸ್ ನ ಯಾವ ತರ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ, ನನಗೆ ಇಲ್ಲೇನೋ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ, ನಾವು ಐಪೀಸ್ ನ ಯಾವ ತರ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೋಬೇಕು, ನಮಗೆ ಇಮೇಜ್ ಲೀಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಡಿಸ್ಟಿಂಕ್ಟ್ ವಿಷನ್ ಅಲ್ಲಿ ಸಿಗಬೇಕು. ಸೊ ನಿಮಗೆ ಗೊತ್ತಿರಬಹುದು, ಯೂಸಿಂಗ್ ಅಡ್ಜಸ್ಟಿಂಗ್ ಸ್ಕ್ರೂ ನೀವು ಏನ್ ಮಾಡ್ತೀರಾ, ಕಾಂಪೌಂಡ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲಿ ಸ್ಲೈಡ್ಸ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ, ಸೊ ಟು ಗೆಟ್ ಅ ಕ್ಲಿಯರ್ ಇಮೇಜ್, ಸೊ ನೀವು ಮೇಲೆ ಕೆಳಗಡೆ ಮೂವ್ ಮಾಡ್ತೀರಾ, ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪೊಸಿಷನ್ಗೆ ನಿಮಗೆ ಇಮೇಜ್ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಕಾಣುತ್ತೆ. ಸೊ ನೀವು ಎಲ್ಲಿಗೆ ಸ್ಟಾಪ್ ಮಾಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಾ. ಸೊ ಇನ್ ದ ಮೀನ್ ವೇ, ಅದರೊಳಗಡೆ ಯಾವ ಥರ ಪ್ರೋಸೆಸ್ ನಡೀತಿದೆ ಅನ್ನೋದನ್ನ ನಾವು ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ ದಟ್ ಯುವರ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ವಾಟ್ ಆಕ್ಚುಲಿ ದ ಥಿಂಗ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾಪನ್ ಈಸ್ ಸೊ ದಟ್ you can adjust the distance between the eyepiece and this object A dash B dash is adjusted to get the image at this distance of distinct division. Serious friends. So eyepiece ಅಂತ ಬಂದಾಗ ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲಿ ಆಂಗುಲರ್ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಫೋಕಸ್ ಅಲ್ಲಿ ಇಟ್ಟರೆ ನಮಗೆ ಏನಾಗುತ್ತೆ, ಇನ್ಫಿನಿಟ್ ಅನ್ನೋ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಬಟ್ ನನಗೆ ಏನು ಬೇಕು, ಕ್ಲಿಯರ್ ಇಮೇಜ್ ಕಾಣಿಸಬೇಕು. ಅದಕ್ಕೆ ನಾವೇನು ಮಾಡಿದ್ವಿ, ವಿ ಜಸ್ಟ್ ಅಡ್ಜಸ್ಟೆಡ್ ಇಟ್ ಸಚ್ ದಟ್ ಟು ಗೆಟ್ ಇಟ್ ವಿತ್ ದ ಲೀಸ್ಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ಡಿಸ್ಟಿಂಕ್ಟ್ ಡಿವಿಷನ್ ಅಂತ ಹೇಳಿ. ಅದೇ ತರಾನೇ ಅಲ್ಲಿ ನಾವೇನು ಮಾಡಿದ್ವಿ, ಅಲ್ಲಿ ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳೇ ಬಿಟ್ವಿ ಅದರಲ್ಲಿ ಆಂಗುಲರ್ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಕೇಸಲ್ಲಿ. ಸೊ ದಟ್ ಇಟ್ ಇಸ್ ಅಸ್ಯೂಮ್ಡ್ ಟು ಬಿ, ಸಿ assume that the object is placed at least distance of distinct division ಅಂತ ಹೇಳಿ. But here we are not doing that. ನಾವು linear magnification ಕೇಸಲ್ಲಿ ಏನು ಮಾಡಿದ್ವಿ, ಸೊ ದಟ್ ಅದೇ ಕೇಸ್ ನಾವಿಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. Hope you got the working principle. ಎಲ್ಲಾದರೂ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ, just working principle ಮಾತ್ರ ಕ್ಲಿಯರ್ ಆಗಿ ತಿಳ್ಕೊಳ್ಳಿ. So now let us move for the derivation of magnification for complete this compound microscope. Here the magnification for this compound microscope can be written as the product of magnification of the objective lens and the magnification of eyepiece. So that the total magnification of a compound microscope can be written as the magnification of the objective lens M0 and the magnification of eyepiece ME. So here I just written it, M is equal to M0 into ME. So to get the final magnification, we should know first we should calculate the magnification of an objective lens, and also we should move for the calculation of magnification of eyepiece. So ನೀವು ಅಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು, ನಮಗೆ ಐಪೀಸ್ ಅಂತ ಏನಿದೆ, ಐಪೀಸ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ಯಾವ ಥರ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಇಟ್ ಇಸ್ ಸಿಂಪ್ಲಿ ಆಕ್ಟಿಂಗ್ ಇಟ್ ಆಸ್ ಅ ಸಿಂಪಲ್ ಮೈಕ್ರೋಸ್ಕೋಪ್. ಅಂದ್ರೆ ಲೀನಿಯರ್ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ನೀವು ಡೆಡ್ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ರಿ, ಲೀನಿಯರ್ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಡೆಡ್ಯೂಸ್ ಮಾಡಿದಾಗ m is equal to 1 plus d by f ಅಂತ ನಿಮಗೆ ಫಾರ್ಮುಲಾ ಬಂತು. ಸೊ ದಟ್ ಇಲ್ಲಿ ಐಪೀಸ್ ಅದೇ ತರ ಆಕ್ಟ್ ಆಗುತ್ತೆ. ವೈ ಬಿಕಾಸ್ ನಿಮಗೆ ಆಬ್ಜೆಕ್ಟಿವ್ ಲೆನ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗಿರ್ತಕ್ಕಂಥ ಇಮೇಜ್ a dash b dash ಆಗಿರೋದ್ರಿಂದ ದಟ್ ಇಮೇಜ್ a dash b dash ಏನಾಗುತ್ತೆ, ಇಟ್ ಆಕ್ಟ್ಸ್ as an object for eyepiece. ಹಾಗಾದ್ರೆ ಟು ಗೆಟ್ ದ ಇಮೇಜ್ at least distant of distinct vision, ಬಿಕಾಸ್ ಆ ಆಬ್ಜೆಕ್ಟ್ ಎಲ್ಲಿದೆ, FE ಅಂದ್ರೆ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಹತ್ರ ಇದೆ. ನಮಗೆ ಇನ್ಫಿನಿಟಿನಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಿತ್ತು. ನಮ್ಗೆ ಇನ್ಫಿನಿಟಿನಲ್ಲಿ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆದ್ರೆ ಇಲ್ಲಿ ನಮ್ಗೆ A ಡಬಲ್ ಡ್ಯಾಶ್ B ಡಬಲ್ ಡ್ಯಾಶ್ ಇಮೇಜ್ ಸಿಗ್ತಾ ಇರಲಿಲ್ಲ. ಸೊ ಡಿಸ್ಟಿಂಕ್ಟ್ ಇಮೇಜ್ ಬೇಕಾಗಿರೋದ್ರಿಂದ ನಮಗೆ ಅಡ್ಜಸ್ಟ್ಮೆಂಟ್ ಸ್ಕ್ರೂ ಇರುತ್ತೆ. ವಿತ್ ದ ಹೆಲ್ಪ್ ಆಫ್ ದಟ್ ಅಡ್ಜಸ್ಟ್ಮೆಂಟ್ we can just adjust the distance between that the object A dash B dash and the eyepiece, so that to get an image A double dash B double dash at least distance of distinct vision. So that ಹಾಗಾದ್ರೆ ನಿಮಗೆ ಇಮೇಜ್ ಎಲ್ಲಿದೆ, least distance of distinct vision ಅಲ್ಲಿ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಸೊ ಲೀನಿಯರ್ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಕೇಸ್. ಸೊ ಹಾಗಾದ್ರೆ what is the magnification of eyepiece? Magnification of eyepiece is equal to the similar to the linear magnification case of simple microscope. First see here, now let us take out ending that the magnification of the compound microscope. Magnification of compound microscope. So I am just writing it as here, we just write it completely. So that the magnification of compound microscope is written as the product of magnification of objective lens and the magnification of eyepiece. So now I am just moving towards the calculation of magnification of eyepiece. What is the magnification of eyepiece? See, eyepiece is acting as a simple microscope. So hagadre we know the formula for linear magnification in case of simple microscope. No need to derive again. Suppose even if you want to derive it, you can. So just by substituting the values and you can make it up. So otherwise simply you can write therefore we know that the magnification of eyepiece ME can be written as 1 plus d by FE. Where is d is the image distance, that is what the least distance of distinct division. F is the focal length of eyepiece. And still we should discuss the magnification formed by the objective lens. Let us see that in the next class. So today we just covered of the compound microscope, that is what the construction and the working principle, and also the diagram, ray diagram related to the compound microscope. Please be careful, definitely you will get the questions especially on the optical instrument, that is on simple microscope also you will get, especially that is what the linear magnification case m is equal to 1 plus b by f naught, and also you will get a question on the compound microscope, that is what exactly the formula that what we just did for the eyepiece. Similarly, we should move for doing out the magnification in case of objective lens. This is about today's class, my dear students. Hope you all gone through the concepts very well. So note down the ray diagrams in the pencil, so that some of you students will just written some diagrams in the pen, so that what I observed while correcting out the notes. So don't go with the pen, just try to draw diagrams in the pencil. And don't forget to represent the direction of rays. Suppose if you forget the direction of rays, and even if the diagram is exactly correct, you will lose the marks. So hope you all written. Thank you, dear students.